Welcome to Siemens NX version 1953 and coding enhancements. When doing coding, first you select the faces you would like to coat. Make sure the normal is going in the direction you want. Next, you have to give it drive geometry, either curves or surfaces. In this case, I'm going to give it a curve that's one of the face edges. That same face edge will be a containment next. So one of the things that's new is the ability to contain the coding. In other words, the coding will be inside the boundary. So I'm going to pick the face edges as illustrated and just select around the part so I get the edges and curves that I want. I'm going to double check the direction of that last curve I picked. Double click on it so that they all go in the same direction. And click OK. All of the output will now be contained within that containment loop. For output and avoidance axis, we're going to be normal to the faces. Then we get into strategy. I'm going to step over 100% of the tool diameter. And I'm going to do a zig cut. For the next options, they work best when you use infills only. Guide curve offset means it's going to take from that guide curve we selected and offset the first bead 50% from it, or whatever we input. In this case, because the guide curve is also the edge of the containment, I want to offset the bead 50%. For the step over skip, when I put in a value of 1, that means it's going to output the beads 1, then skip 2, then do 3, then 5, then 7, then it's going to go back and do 2, 4, 6, 8. It's a way to do the odds and then the evens in that order. Minimum cut length means it will not make an output unless the output is at least that long. So I'm going to go ahead and generate that operation. So if we look at the beginning of it, we can see that the first bead is offset 1/2 the bead width from our drive curve, or the edge of that face. That's because we used a 50% offset. Notice here in the corner, because of the minimum cut length, it does not make extra beads in that corner because they are not at least that length. In this case, we gave it a length of 50 millimeters. It does not make a bead unless it's at least 50 millimeters long. Next, if we do a quick simulation, what we'll see is that it's going to output first all of the odd passes, and then it's going to output the even passes. So once I click play, you see it doing a fairly large step here because it's just doing 1, 3, 5, 7, all the odds. Once it gets to the end, then it's going to go ahead and do all the evens. And to save time, we'll just skip ahead and show you that. So now it goes back and it does the evens. These enhancements to coding are really useful for people who do multiple plies of parts. In this case, I have a coding operation with a guide curve in one direction, and another coding operation with a guide curve in a different direction, and then a third direction. And if I look at this, you can see the different beads will be created in different directions. And I've got 3 different levels or plies of beads. So the coding with the containment, the skip, and the minimum cut length allows you to do plies of parts so that you get strong yet lightweight additive manufacturing bodies. Thank you.